What's up? What's up? It's your man Jimmy Chan. All right, so today we're going to be talking about factorial notation and permutation. Okay, so here it goes. Factorial notation says that if n is a positive integer, then the notation n exclamation point, which reads n factorial, is a product of all positive integers from n down through 1. Okay, so we have this right here as a show. It is pretty confusing. So here's what I'm going to say to you. If I, let's say, ask for 3 factorial, that would be 3 times 2 times 1. Okay, if I said 5 factorial, that'd be equal to 5 times 4 times 3 times 2 times 1, right? So whatever the number might be, that's where it would start. So this 5 factorial, so it starts at 5, then 4, then 3, then 2, then 1, okay? If it's 20 factorial, it'll be 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, all the way down to 1, okay? So it decreases by 1 as it goes, okay? That's factorial notation. All right, permutation is an ordered arrangement of items that occur when no item is used more than once, and the order of the arrangement makes a difference, meaning that when order of arrangement makes a difference means that ABC is not the same as BAC, because the order makes the difference, which is also not equal to CAB. Okay, so that's why the order makes a difference. All right, and the formula for permutation is this right here, where N is the number of items and R is the number of possible permutations. Okay, so for example, you have 12 cars and you want to pick 3 of them, right? So out of how many that you want to pick, how many, all right? So that is the formula for it, which is n factorial, which comes from this, which is the number that you have, right? Number of items that you have, and then n minus r, okay? So how many you're going to pick is the r, okay? And then there is also a formula if there is duplicate items, meaning that anything that repeats, right? Because in case if I have, repeating items, like if I had the alphabet done twice, then each of them would be down here as well, and not just the number that is there, all right? And we'll talk about examples for that, all right? So let's head back up to factorial notation, and let's do an example. So for example, right here, we have 12 factorial divided by 12 minus 2 factorial. Well, just like regular math, I would do parentheses first. So I'm still going to have the 12 factorial. On the bottom, I had to do the parentheses first, so I have 10 factorial. All right. Well, what is 12 factorial? Well, 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Put that all over 10 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And what you will notice is that this part right here of the fraction looks exactly the same on top as on the bottom. So those two can actually cancel out. So what I actually have left is 12 times 11, which is going to give you 132. And there you go. All right. So 12 factorial would be a really big number, but divide by 10 factorial, you have left 132. All right. All right. So that would be factorial notation. So let's talk about permutations. All right. So we have 8 performers who will present their comedy acts this weekend at a comedy club. One of the performers is insist on being the last stand-up comic for the evening. Okay, if this performance request is granted, how many different ways are there to schedule the appearance? So in this case, there is a key part right here, that the one of the performers insist on being the last stand-up comic for the evening. So remember, there is a total of 8 performers, okay? Since there's 8 performers, one of them already insisted being the last one. So if I had to pick from these 7 performers, so my N is the 7 performers, my R I have to pick for 7 spots. So really what I have here is P, I got 7 performers and I got to pick for 7 spots, right? So if that's the case, then the formula for this is 7 factorial divided by 7 minus 7 factorial, which says 7 factorial divided by 0 factorial. Well, 0 factorial is what? 1. Okay. I don't need to do that. So 0 factorial equals 1. All right. So that means anything over 1 is just itself. So let's see what 7 factorial comes up to be. So that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Let's see. 6 times 5 times 4 times 3 times 2 times 1. So I'm going to have 5,040 different ways. Okay? 5,040 different ways to schedule these guys. Right? Luckily, there wasn't all 8 of them. Good thing that last one volunteered to be last, because there's 5,040 ways already with just 7 of them. Okay? All right, another example. A race in which 6 automobiles are entered and there are no ties, right? There's no ties. How many ways can the first 3 finishers come in? Okay, so how many do I have to choose from? I have 6 to choose from. I have to pick 3 of them because I want the first 3 finishers, right? So that means I have 6 and I gotta pick 3 of them. So I'm gonna have a 6 factorial over 6 minus 3 factorial, right? So I got 6 factorial over 3 factorial. So I got 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. So all I'm left with is 6 times 5 times 4, which is going to give me, I believe, 120 different ways. Yep, 120 different ways of these 6 cars finishing first, second, and third. Okie doke. All right, so over here, how many distinct permutations can be formed using the letter of the word, using the lettering of the word bookkeeper? Okay, so let's take a look here. How many letters do we have? We have 2, 4, 6, 8, 10 letters, right? Okay, so 10 letters. In bookkeeper. Okay, all right, so if we look at bookkeeper, what letters repeat? Okay, there is 2 O's, there is 2 K's, there is 3 E's. Anything else? Let me see. The P doesn't repeat. The B doesn't repeat. Okay, E and the R doesn't repeat. Okay, so that's what we have. So this is when the permutation of duplicate items come into play. So in this case, I'm going to have the 10 factorial divided by the 2 factorial, 2 factorial, 3 factorial. This is for the O, this is for the K, and this is for the E. Okay, now this is a little bit different. So sometimes writing it out isn't bad for the math part. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 times 3 times 2 times 1. Okay, so I have that 2 factorial, 2 factorial, and 3 factorial on the bottom. So, however, what you see is that the 3 times 2 times 1 can cancel with the 3 times 2 times 1, right? And then 2 times 1, here, let me use a different color. The 2 times 1 times 2 times 1 can get rid of the 4, because that way you go to 4, all right? So what I really have here is the 10 times 9 times 8 times 7 times 6 and times 5. Question is, what is that equal to? So let's take a look. Times 8 times 7 times 6 and times 5, and we get 151,200. Okay, and there we go. I hope that answers your questions. If there's anything else, please let me know. Talk to you later. See ya. Bye.